Welcome to This Explainer. Today, we're looking at something absolutely fascinating from our source material: how to build truly intelligent AI agents. The easiest way to wrap our heads around this is to think of it like a video game progression. We're going to start with a super basic level 1 chatbot, and step by step, we'll figure out how to level it up. We'll give it tools, memory, human supervision, and finally, a literal superpower, where we can time travel through the AI's actual thought process. It's going to be a fun ride. Let's master LangGraph together.
So here's the structural roadmap of the 5 levels we are unlocking today. Level 1, the basic chatbot recap. Level 2, equipping bots with tools. Level 3, adding memory and threads. Level 4, human-in-the-loop control. And finally, Level 5, the one you're definitely going to want to stick around for, the time travel superpower.
Okay, let's dive into this with Level 1, the basic chatbot recap. To really appreciate the superpowers we're about to add, we have to establish our baseline, right? The source material uses a brilliant analogy for this: the restaurant waiter. Think about a standard chatbot like a standard waiter. You walk in, they take your order, serve your food, you pay, and you leave. The next time you come in, they have zero idea who you are, totally forgetful. But an agentic waiter, the kind of advanced bot we're building with LangGraph, is a whole different ballgame. You walk in, and this waiter says, "Hey, last Thursday you ordered the pasta, and since it's super warm out today, how about a nice coffee with that?" It interacts, it personalizes, and it actually executes automated workflows based on context.
Now, to make that agent waiter a reality, the AI absolutely has to remember the conversation. In LangGraph, you do this by defining a state. Just think of state as a global structure that holds all of our messages. But, and this is key, it isn't just some static list. It's continually updated via what's called a reducer function. Whenever a new message comes in, this reducer function decides, hey, do I just append this to the list? Do I update an existing message? Or do I actually need to remove something old so the AI keeps the right context? This state is literally the lifeblood of our AI agent. It passes through every single node in our graph.
Moving right along to Level 2, equipping bots with tools. So, our bot has a basic structure and it has a state. That's great. But on its own, an LLM is trapped in a box. It only knows what it was originally trained on. So how do bots actually search the web or access your private databases? The source points to function calling. They show how to bind the LLM to a search engine tool, like Tavily. But let's peek under the hood at how that connection actually works.
Here is the exact flow of tool usage, and honestly, this is a major aha moment for a lot of developers. The LLM itself does not search the web. The LLM simply decides that a tool is needed based on whatever prompt you gave it. It stops generating text and essentially outputs a message saying, hey, I need to use the search tool and here's the query I want to run. That is step 1. Step 2 is where LangGraph really shines. It has a dedicated tool node that catches that request, executes the actual Python function in your local environment, and then, for step 3, takes that raw data and hands it right back to the LLM. Then the LLM formulates a nice human-readable answer for you. The system is executing the action. The LLM is just the brain routing the request.
All right, time for Level 3, adding memory and threads.
Even though our bot can search now, we still have a massive limitation: the goldfish memory problem. The second your coding session ends, boom, the bot forgets you. We need persistent memory. And this brilliantly illustrates how LangGraph handles it. The instructor compares state to a shared fridge in a house. Every component, every single node in your AI graph can walk up to this fridge, put data in, take data out, or just check what's inside. Because the state is globally accessible like that, we just need a way to keep the fridge running even when we turn our laptops off. To pull that off, LangGraph introduces 2 really crucial concepts: the thread ID and the checkpointer. Imagine you're chatting with the AI, and I'm having a totally different conversation with it at the same time. We isolate those sessions using a thread ID, a unique identifier just for your chat. Then we use a checkpointer. Now, if you're just prototyping, you might use a simple in-memory saver. But in a real-world app, you'd hook this up to a database, like Postgres. Every time the graph runs, it saves the state to that database under your specific thread ID. So when you come back tomorrow and ask, wait, what was my name again? Lang grabs your thread ID, pulls your history from the checkpointer, and the AI seamlessly picks up right where you left off. Which brings us to Level 4, human-in-the-loop control.
Think about this for a second. What happens when your AI is doing something highly critical and you absolutely cannot afford for it to make a mistake? You have to introduce human supervision. The text gives this fantastic analogy of a kitchen agent. Imagine an AI chef. It goes from step 0, prepping all the ingredients, all the way to step 10, serving the dish. But
What if at step 5 it decides it wants to add a massive handful of salt? You don't want it to just proceed automatically. You want a pause button. You want the workflow to freeze right before the seasoning goes in so a human can taste it, verify it, maybe adjust it, and then give the green light to continue.
On a technical level, LangGraph handles this so elegantly. When you compile your graph, you can use a command called interrupt before. This lets you specify exactly which node acts as the pause button, like say right before an external tool is called. When the AI hits that node, execution freezes. As the developer, you can read the current snapshot of the graph. Let's say the AI formulated a terrible web search query. You can actually step in, use the update state method to manually rewrite that query, and then just resume execution. The AI wakes back up, completely unaware it was ever paused, and moves forward with your corrected data. It's the ultimate safeguard.
And finally, Level 5, the time travel superpower.
Okay, this final capability feels like pure science fiction. We're talking about the ability to literally rewind a chatbot's exact state to a specific second in the past. Imagine pausing a bot, scrolling back through its exact thought process minute by minute, pinpointing the precise moment it made a bad decision, and overwriting that moment in history just to see how the future changes. That is time travel in LangGraph.
To pull off this time travel replay, you need 3 specific components, all of which we've been building up to today. First, your graph configuration. Second, the thread ID, so the system knows whose conversation we're analyzing. And third, the magic key, the checkpointer ID. You see, because we equipped our bot with a checkpointer back in level 3, it hasn't just been saving the final outcome of the chat. It's been saving everything along the way.
So the crucial point is how this storage mechanism actually behaves. Every single time your graph moves from one node to another, like jumping from the chatbot node to the tool node, it acts like a camera click. It takes a complete, isolated snapshot of the state at that exact millisecond, and it assigns it a unique checkpoint ID. Using a method called get_state_history, you can pull up a list of every single one of those camera clicks. You can grab a checkpoint ID from 10 minutes ago, feed it back into the graph, and watch the AI replay its exact actions from that point. Actually, scratch that, it gets even better. You can update the state at that past checkpoint, effectively branching the timeline to test entirely different outcomes or fix deep-seated bugs.
Which brings us to a final provocative thought for this explainer. If you have a framework that lets you give an AI tools, persistent memory, human oversight, and the ability to rewind and rewrite its exact thought process at any given second, what limits remain for scaling truly intelligent agents? LangGraph takes AI completely out of the black box and puts the control firmly in your hands. It's an absolute game changer for debugging and development. I highly encourage you to get out there and try building an agentic workflow yourself. Thanks so much for joining me on this explainer, and keep exploring.